Hello, and welcome to this episode of Cal TV, sponsored by Calvary Robotics, Advancing Automation. I'll be your host today. My name is Joe Gemma. I'm the Global Vice President of Calvary Robotics, and I'm honored to have as our guest today, Carl Doakson. Carl is the Global Director for Automation Robotics at 3M. Carl, welcome, and thank you for joining us today.
Hey, thanks, Joe. Good to see you again after Automate.
Thanks. Yeah, it's an exciting time in the industry for sure. And one of the topics, I mean, you've certainly had a lot of experience in this space and moving from dangerous manual tasks to automated, semi-automated technologies and material movement. We'd like to explore that topic with you. But before we go there, and as a global leader in the industry for a company that's been, I'll say, innovating since its inception, we're keen to hear more about the changes in technology and technological approaches to material removal. But you certainly have seen a great deal of development and growth over the years, particularly around the materials. And we'd like you to share perhaps your perspective with our audience. However, before we get into our discussion on that topic,
Sure,
we'd like to ask our guests to share a little bit about their personal work history and how your career got to where you are, how that progressed. Could you tell us a little bit about yourself and your career?
Yeah. And so, Joe, I'm a 30-year guy at 3M. I actually started out of university at Honeywell in Minneapolis, but then started at 3M. In those days, I applied for a job. An ad was in the paper in the want ads. I got interviewed and got a job at 3M, and started out actually in finance and accounting. I'm a CPA, but after 4 or 5 years at 3M, I got a shoulder tap. They asked if I was interested in marketing, business development. Moved over there at a time when marketing was really just about training future sales managers. There really wasn't this concept of professional marketing. And so I got to be one of the first marketers to go through that program, and it was exciting. It meant the globe, international. And so since then, I've done assignments for 3M, lived in Europe twice, lived in China for 5 years. That's where we first met, Joe, in Shanghai when you were the IFR president. And I've also spent so a lot of time in international operations, but also Lean Six Sigma. And I just to segue into my robotic experience, this story. I was living in Shanghai in 2013 through 2018. And that's right when China was really starting to take off in the automation industry. KUKA was right there in Shanghai, as was ABB, as was Fanuc Shanghai. And I was able to start a lot of those relationships in Shanghai. And my boss at the time, every time she would come over to China, we would just take her to robot companies, end users that were using heavy automation to use their 3M products that they bought from us. And my this was probably around 2016, 2017. I was asked to lead this. She was, why don't you lead this robotics thing, start a new business? And kind of the rest is history. Yeah, I've been doing that since 2017, and really appreciate, Joe, the mentorship over the years, helping me stay connected, in the robotics industry. So I could go on and on, as you know, about my love of robots and how I got into it.
Well, thanks for sharing that, and certainly I'm thrilled that you got involved because it gave us an opportunity to meet each other, share a lot of experiences together, and certainly build a friendship. So thanks for that. And by the way, for our younger readers, you mentioned looking at a want ad in a newspaper. Yes, when we were younger, there was such a thing as newspapers and want ads. So for our younger listeners, we didn't have the advent of you have today of LinkedIn and other tools to look for opportunities to work in the workforce. Anyway, I thought it was pretty interesting you shared that.
Yep.
So since you participate as a board member for the Robotics Technology Sector Board of the A3, and you also work with the IFR, you mentioned earlier, International Federation of Robotics, you have both a broad perspective on the dynamic changes in the industry and particularly around the biggest challenges. Perhaps one of the biggest challenges globally today has been the limits in the availability of workers across almost every industry. How has that affected companies you work with on producing products to meet their customers' expectations?
Yeah, Joe, that topic is at the very top of every list, and with the customers and our partners that we talk to, it's a very critical issue. And now, when I visit customers, um, post pandemic or even during the pandemic, it's just been exacerbated, that issue. Because even if you remember going into the pandemic, there was these articles on a shortage of manufacturing workers. And just in the US alone, I think the numbers approached 2 million, just based on people retiring and the growth in the industrial economy. So there's a shortage. Enter the pandemic that sent shockwaves through the supply chain and through the labor markets. Now that shortage is even when I talk to customers, it's, well, I can't find people to hire. Even if I am able to hire somebody, I'm unable to retain them. So everybody's looking to automate, and I think this is what was driving the Automate show, and then the other show, the European show, Automatica, that I was at. People now they definitely want to automate when we talk to them. And that labor shortage is driving that. I would say the other thing that's going on is the long supply chains that have been developed over the years. And that's not, I was at one customer in Germany last month, and they told us just in time is dead. There's no such thing anymore. We need local service, local supply, local inventory. And, you, 3M, we need you to invest in that and help us create these local supply chains for our biggest plants around the world. So all of these topics, economic megatrends right now are converging to, it's a real wake-up call, because the only way you can compress those supply chains, reshore, is to automate. I mean, and so it's our industry, the automation industry is getting a nice tailwind from that right now. And like you said, critical issues. What does it mean? It means full order book. It means a backlog. Lots of good problems to have for our industry.
And I agree. And the supply chain is a critical thing. In fact, I saw something recently. Manufacturers that thrive or have been thriving, they found clever ways to connect, operations, processes, software, but particularly the supply chain to be more reactive to the market. So it's a very valid point you bring out. And I'm not surprised that your customers have said to 3M, look, we need you to be part of this process to improve this. And that's something else you mentioned, the pandemic. And it's true. Even with some previous guests, we've discussed that before the pandemic, companies around the world started increasing the use of automation. Did you see this happening with the material removal applications also prior to the pandemic, or is that a more recent development?
No, I think material removal really started to get traction maybe in the last 10 years, and when I look, people that have been trying to elevate that application, certainly, it's people like me, and then, Bob Little and his team at ATI. It's a application that has a bright future, and it's not easy, and which is good and bad, but there aren't a lot of people that can do it. And I always tell the story that, again, I'll date myself, but when I walked into an assembly plant as a kid, the Ford assembly plant in St. Paul, which is no longer there, but there were human operators spraying the undercoating, painting the cars, doing the, welding. And then, in my current job at 3M, I started traveling the world. I walk into these assembly plants, fast forward, 20, 30 years, and none of that, those jobs are done by humans anymore. However, when you walk through an assembly plant, there's a lot of grinding, sanding, polishing, deburring that's still done all by human operators. Now, that is, it's not limited to automotive assembly, of course, but those industrial customers of ours are saying this is one of the last bastions for automation. If we're going to have, for example, in automotive assembly, a lights out paint shop, we need to automate the sanding, polishing, and deburring, and in grinding in some cases. So I'd say that that was getting going pre-pandemic. Now the pandemic has obviously accelerated that. Why? You have those operators work in very close quarters when you're doing those applications. Grinding is not as skilled as, say, welding, but it's still a skilled position. And our customers suffer from high turnover. And I would, the other thing about the last comment about this was happening pre-pandemic, but you call it the Amazon effect, right? When Amazon builds a warehouse in a rural area where a lot of our factories are, all of a sudden those are really good jobs, right? And for the first time I can ever recall, there are certain instances where service jobs like those jobs are actually paying just as good, if not better, than a manufacturing job. And that is something, it's the new normal, right? So we're not going to be able to compete, and you're not going to be able to hire a young person to do grinding all day like we have for the last several decades. So people are recognizing that, and no doubt the pandemic is accelerating those trends.
Yeah, that's a good point. We're all actually vying for the same limited workforce, and so it's becoming more of a challenge. And that's why, as you said, automation is potentially a solution to support the productivity needed. And material removal, as you mentioned, especially from 3M's perspective, been around for decades. And maybe some of the reasons it's more relevant today in terms of automation is because of the lack of workforce. Are there other things playing into that, do you think, in terms of making it more viable as an alternative today, utilizing automation for material removal?
Yeah, there's a couple of trends that we track. I mean, certainly one of those was this invention, creation of active compliant force control, and allowing the robots to feel and adjust has been a tremendous boost for our applications. Still a lot of work to do on those devices, those end effectors. I'll probably talk about that more, but those continue to improve, and that's been a breakthrough that's allowed us to attack applications that we probably would not have been able to, say, 10, 15 years ago. The other one, I think the computing bandwidth. I was at one of our integrators, I don't know, it was last year, and he was explaining that this box has more computing power than a supercomputer did. I don't know, 5, 6 years ago, that kind of a thing. So that's Moore's law. What does that mean? Well, we can store, literally millions and millions of images, and which is important in material removal, scan to path, scan to plan, those types of, that type of, programming is important for us. And I'd say right up there with the decreased cost in computing bandwidth is also cameras. That some of these sensor camera bays have dozens of cameras. And as you know, those cameras are cheap now, if you can find the ones with the right chips.
Yeah.
But
different
the
problems.
cost of cameras has come down tremendously. And this is enabling. So one of the things in material removal is just a general awareness that it can be done. People tend to think of it as kind of a black art, and I have one guy in my plant that knows how to do it, and there's no way a robot would be able to figure this out. And I can pretty much, I talk with our technical team and others in the industry, always throw down the challenge. Hey, there's no question any material removal application can be automated today. The technology is there now. And arguably it wasn't there 10 years ago.
Mm-hmm.
It's not a technology question. The real question is, can a system integrator make money on that job?
Mm-hmm.
Now, that's an unknown, and that's what we're competing with. When material removal, well, if it's machine tending, I know I can make money on that.
Mm-hmm.
But if it's grinding, or dimensioning, taking a part from A to B, RA finishes, all that type of, the technology's there, no question. Now, can the, and of course that for a system integrator, then pricing comes into play, and, do you have the right experienced workforce to program the robots? The list goes on, but it really comes down to that. Can an integrator make money on a material removal job? And certainly that's a big part of my job, is to help, system integrators and our customers look at those economics based on, a lot of empirical data.
Well, it's interesting. I mean, you actually indicated from what you just described that the market's really responded in terms of technologies to support material removal. And I would say, one of the things driving some of that even is the demand for productivity. Some of the companies I visit, they say, if I can't get this done, I don't have the people, I can't sell the product, I can't keep my business going. So that whole dynamic has changed actually from that perspective. So I'm curious from your perspective, what markets or industries seem to benefit most by bringing, I'll say, this automation or semi-automation to the masses that we couldn't address in the past?
Well, I do think that, again, in our world of industrial automation, the legacy is, low mix, high volume, right? So if it's low mix, high volume, and then I'd add a third element, third variable is expensive parts. So in general, when it comes to material removal, that means industries such as aerospace, medical implants, Warsaw, Indiana, those types of accounts. Why? Because it's relatively low mix, it's high volume, and it's very expensive, titanium, high nickel alloy type parts. And the ROI has historically been there. Those two industries, jet blades, aerospace, but land-based, gas turbine blades as well. These are very expensive parts that have tended to lead in robotic material removal as medical implants. And then I'd add another industry, consumer electronics, which, as you know, Joe, we traveled there together to southern China. That is a very unique geography, very unique market, where I call that is the mother of all low mix, high volume applications. So when you're polishing mobile phones, laptops, tablets, PCs, television sets, frames, in some cases, that is big business. And we saw that move quickly from manual sanding sponges and blocks to within just a very short period to 100% automation. And that's a big market that a lot of us here in the U.S. don't realize how big that is. But that's
a really good point too, because that's seen as a low cost labor market, yet they embraced automation technologies to do those processes very early on. Right.
I always think, from our IFR days, this robot density. When you look at the robot density, Japan, Korea, Singapore have these tremendously high, disproportionate robot density figures, and it's driven by the consumer electronics industry, which really doesn't exist like it does in Europe or the US, like it does in Asia. And Yeah, and I mean, there's a segue there in China when I was there, because of those lead, penetration into aerospace, medical implants in China, consumer electronics. The Chinese were very aggressive in deploying robots for material removal in other, cutlery, pots and pans, those types of industries, sporting goods, golf clubs especially, are very popular. Builders hardware, hinges,
Absolutely.
plumbing fixtures. I just add a special market. It's more of a U.S. thing, but firearms as well, as we know, especially in the U.S. is a big market for robotic polishing, sanding, deburring as well.
Yeah, I would say that's a good point. That's actually a growing market, again, because volumes in productivity needs in that
Yep.
market, and the finite finish that you're looking for as a consumer product. So, we talk about different technologies. You talked about some of the impact that technology have had. I'm curious for our listeners. Do you think some of this newer technologies like AI and collaborative robots? I hate saying cobots that's a term, but at least the application.
You taught me, Joe. There's only collaborative applications. No such thing as a collaborative robot.
Exactly.
Right? Yeah.
But so do you think they've impacted that shift at this point? Or you think that's going to have more of an impact going forward?
Yeah, I mean, no doubt, AI and adding this predictability. I'd love debating with some of our colleagues. Melanie Wise, what is AI? Come on, does it exist? Type thing. But really, if it's predictability, statistics, that's helping. It's helping us, whether that's
Good data.
through
Good
the
data, not
data
just
or
big
also the images and the video that you can capture now to improve upstream processes to the predictability on when is the product going to fail, so you can make the appropriate adjustments before it fails, that type of thing.
Good point.
That obviously is benefiting the robotics industry. Collaborative applications, like you said, they're possible now thanks to Power Force Limited, robots. Very popular tool. In the material removal world, those things have been pretty much limited to random orbit sanding, lower payloads. You know the drill. But there's more. The payloads are going up. The robots will continue to get stiffer or more robust to be able to handle some of these more demanding material removal type jobs. And I just think that collaborative robots for collaborative applications, they're part of the ultimate cost equation. Because
absolutely,
if you have a cell that's all caged in and light curtains and everything, it's going to be more expensive. The only way you start to get to this sweet spot of a sub $100,000 robot cell is with one of these collaborative robots. So we're seeing a lot of that. This lead applications where people are pushing the envelope on what does it take to get in as an entry point, and that that's the ticket. I know, the other thing at Automate was this whole small, medium-sized enterprise, that mega trend, people chasing that as an untapped market. You're not going to get into small, medium-sized businesses by offering, $1 million robot cells. You've got to be in that, at the attractive price point. And at least for now, those types of cells, the concepts I've seen, usually it involves a collaborative robot.
Yeah, I think you hit right something really relevant there. The small medium-sized companies, a lot of what they're doing very often is it's a high mix and low volume, and so to have to reprogram and manage the cell different with a collaborative application or robot applied that way, you can lead to teach. It gives them a more flexibility to work on, again, the high mix and the low volume. So you got a new part in, you make commitment for a small volume to somebody, you can modify your cell much more readily with a collaborative robot because of the way the architecture is built. Now, as you said, some of it still needs to, as far as the suppliers, work on broadening what that product portfolio looks like. Some of the major companies have already done that, and they're going to continue to expand in that area. But I think the small, medium-sized companies that you just referenced will benefit from that advancement through those technologies, and even the AI. Being able to benefit from that data, again, good data, and utilizing it. It helps the small, medium-sized companies as much as, if not more than, some of the larger companies be able to utilize that information more quickly and having to go out to another resource to be able to try to get that. So,
I mean, absolutely, Joe. You talk about labor shortage, and again, it's not limited to heavy industry like I was just describing. Yeah, I talked to a paint shop manager in a car plant, and he's, I can't find any people to hire, and they quit after I train them. Well, think about the robot industry. What robot programmers, right? How do you know, our friend at Superior State, University, he says they're hiring, people are getting job offers, in their sophomore year now, and 6, 7 job offers. There's just not enough robotic programmers, people with the right balance of software, mechatronics to do what we need them to do, mainly with the teach pendant. So make it easier. Just like I think we saw this at Automate, and I definitely saw it at Automatica. How can we make it easier to program a robot? So maybe a technician or an engineer that doesn't know anything about the robot programming languages can actually start to program and troubleshoot the robot with the right, tool set. That's definitely, and that will help not just the small, medium-sized accounts get started, but also the large accounts that can't find people to hire people to program their robots.
Yeah, and you hit on something really important too. I think that with the education community working, Lake State's certainly one of the leaders that way of trying to give them a more multidisciplinary background, practical background going out to the market. When we came out of school, and I know I'm a bit older than you, but it was mechanical engineering or electrical engineering or civil engineering, et cetera. But it's not, those lines have blurred. So having an understanding across it, not necessarily being an expert in a particular area, but having that cross-pollination of understanding is a real benefit to the space. And as you said, the technology is getting better where the software is not as, I'll say, complex. It's kind of like when we went to school, we weren't allowed to use a calculator. We had to do all the calculations on paper. Now you're expected to have a calculator because that tool is there available to you. And it's the same thing happening in our industry, is that tools are available to that we can use, but you have to have some good general understanding. And the education community is stepping that up. And I certainly like to see that more broad-based across multiple I'll say education environments across the country rather than just pockets of it. But it is moving in the right direction. It's certainly benefiting the industry, and some good jobs and good quality jobs and good opportunities for students coming out of school.
It's a little, I come from 3M. We're an army of chemical engineers here at 3M. But we have our share of, double E's and mechanical engineers. And so, especially for people getting started or people that are interested in the robotics industry, I always, I'm on the education committee, of our A3, and Jim from Lake Superior State is on that committee, and we always talk about the importance of software. That get that degree in mechanical engineering or electrical engineering, but make sure you have a minor in computer science, or you get appropriately, amount of experience doing that, because that's the future. The future, you and I came up in a mechanical world. The patents, the intellectual property was all about the mechanics
True.
or the mechatronics. The future, and we even see this, in our company, the future's in software. That's where the intellectual property is. That's where the differentiation is going to be. And I see those up and coming engineers, when they have a knack for, Python or C++ or ROS. And I mean, their careers just move much, much faster these days than somebody that just flat out isn't interested in that. You can really tell a difference now.
Yeah, I can tell you, even at our company at Calvary, not so long ago, it was heavily weighted from the mechanical side as far as the engineering capabilities and resources within the group. But today, I can tell you, it's weighted much more the other way. The robot programmers, controls, PLCs, all the software. We have more in that engineering capacity and capability of a resource in the organization than we do in the other disciplines. We need the other disciplines for sure,
Right.
but that is the area that continues to grow because, you say, it's more around software, and even the data and managing that is all going to come from more of the software and understanding on that side.